Here we have a set math problem. Okay, let's go to the question. In the xy plane above, the graph of the equation y equals to a times x positive 4 times x negative has a vertex at point P. If the graph intersects the x-axis at points R and S, what is the area of triangle RPS? Okay, here we have to find the area of this triangle RPS over here. Let me draw a vertical line from the vertex P to the side RS of the triangle. Since it's a vertical line, it intersects x-axis over here at right angle. So this vertical line segment represents the height of this triangle, and the side RS of the triangle over here represents the base of the triangle. Now to get the area of this triangle RPS, we have to use the formula that is base times height divided by 2. Here the base is given by the length of the line segment RS over here. The height is given by this vertical line segment. So now to get the area of this triangle RPS, I need the length of this line segment RS and the length of the vertical line segment I have drawn over here. Okay, to get the length of the line segment RS over here, I have to find the two x-intercepts of the parabola, because this R and S represent the x-intercepts of the parabola. Okay, to get the x-intercept, what we have to do is we have to plug in y equals to 0 into the equation of the parabola. Okay, let me say y equals to 0. When y equals to 0, the stuff that is equal to y also must be 0. That is a times x positive 4 times x negative 2 equals to 0. Okay, since a is a constant, we can divide both sides of this equation by a. Now this a will cancel. We get x positive 4 times x negative 2 equals to 0 divided by a is 0. Okay, here the product of two binomials is equal to 0. So whenever the product of two quantities is equal to 0, either the first one has to be 0 or the second one has to be 0, or both of them may be 0. Okay, if the first one is 0, we get the equation x positive 4 equals to 0. If the second one is 0, we get x negative 2 equals to 0. Okay, here we can solve for x in this equation. For that, we have to subtract 4 from both sides of the equation. Positive 4, negative 4 will cancel. I'm getting x equals to negative 4. Let me add 2 to both sides of this equation. Negative 2, positive will cancel. I'm getting x equals to positive 2. Okay, here I got the two x-intercepts of the parabola. So negative 4 and positive 2. So let's mark this x-intercept negative 4 over here at the point R, because this is the negative side of x-axis. And let's mark this positive value 2 over here at the x-intercept as, because this is a positive side of x-axis. Okay, here what is the distance from this point negative 4 to the origin over here? So clearly that's 4 units of distance. So in xy plane we have a negative value, but when we consider the distance, we have to consider it as a positive value. That is 4 units of distance we have. And here, what is the distance from origin to this point S? So that is 2. So here we have 2. So when I add this 4 and 2, I am getting the distance from R to S. So that is the length of the line segment RS. That is 6. So this 6 is the base of the triangle. Okay, here I got the base of the triangle. Now we have to get the height of the triangle. To get the height of the triangle, what we have to do is we have to get the y coordinate at the vertex point P. So the y coordinate, the point P represents the height of the triangle over here. So that's the length of the vertical line segment. And also we have the vertex P on the positive side of our axis. So whatever y coordinate we get over here at point P, so the same can be taken as a height of the triangle. That is the length of this vertical line segment. Okay, so to get the y coordinate at the vertex P, first we have to get the x coordinate. How do you have to get the x coordinate? Here we have the two x-intercepts of the parabola, negative 4 and 2. To get the x coordinate at the vertex P, we have to find the average of the two x-intercepts, negative 4 and 2. For that, we have to add negative 4 and 2 divided by 2. When I combine negative 4 and positive 2, I am getting negative 2. When I divide this negative 2 by 2, I am getting negative 1. So this negative 1 is the x coordinate at the vertex of the parabola. Now to get the y coordinate at the vertex, we have to plug in this x coordinate negative 1 into the equation of the parabola we have over here. Okay, now let me take the equation as it is. It is y equals to x positive 4 times x negative 2. Now let me plug in the x coordinate of the vertex, that is x equals to negative 1. Then we get y equals to a times negative 1 positive 4 times negative 1 negative 2. Y equals to a times, when I combine negative 1 and positive 4, I am getting positive 3. So when I combine negative 1 and negative 2, I am getting negative 3. So then we get y equals to 3 times negative 3 is a negative 9. Negative 9 times a is a negative 9a. Okay, here I got the y coordinate of the vertex, that is a negative 9a. So as I said earlier, since we have the vertex on the positive side of y-axis, whatever y coordinate we get over here at the vertex, the same can be considered as the length of this vertical line segment, that is the height of the triangle. So the height of the triangle is a negative 9a. Here we may think the height of the triangle is a negative value. Actually, this negative 9a is not a negative value, it is positive. Because here we have negative 9, it is multiplied by a, this a is negative. So the reason is a is the leading coefficient over here. Since the parabola opens down, the leading coefficient a has to be negative. When I multiply negative 9 by a negative value, that is a, so the negative 9a will be positive, so the height of the triangle is positive. Okay, here we got the base of the triangle 6 and the height of the triangle negative 9a. Now we can find the area of the triangle RPS. Okay, now let me write the stuff over here. That is the area of triangle RPS equals to, the formula is base times height divided by 2. Here the base of the triangle is 6 and the height of the triangle is negative 9a divided by 2. Here 2 goes into 2 1 times and 2 goes into 6 3 times. When I multiply this 3 and negative 9a, I am getting negative 27a. So therefore, the area of triangle RPS is negative 27a square units. We find this negative 27a in answer choice B. The correct answer choice for this question is B.